What if I told you that you could program a powerful AI, not with lines of code, but with simple, structured English sentences? We're about to break down a really revolutionary white paper that suggests we can turn these huge creative language models into predictable rule-based engines just by talking to them in a very specific way.
Okay, let this quote sink in for a second. This is the core idea, and it is a huge one. The author of the paper, who goes by ShadowK, is basically saying we're not just giving an AI suggestions when we write these rules. We are defining the physics of its reality. It's a bit of a mind-bending concept, so let's dig into how it was even discovered.
And what's so cool is that this story doesn't start in some giant corporate AI lab. Nope, it starts with one curious person who noticed something really strange about how these AI models behave.
So who is this ShadowK? Well, what's fascinating is they're not your typical AI researcher from a big tech company. They build game engines, they write novels, and they teach math. Think about that combo for a second. You've got the logic from mathematics, the world building from writing novels, and the systems design from building game engines. It's that unique perspective, that mix of skills, that led to this incredible breakthrough.
This was the simple question that started this whole journey. ShadowK noticed that whenever they fed a language model a specific kind of structured text, it would just snap out of its usual creative, sometimes hallucinating state and become way more stable and predictable. The mission to figure out why that was happening led to a massive discovery.
And that discovery was this. You can actually, fundamentally, change how an AI operates. You can shift it from being a creative partner into something ShadowK calls a simulator.
So here's the crucial point. It seems like these language models have two different states they can be in. On the left, you've got creative mode. That's the one we all know. It's unpredictable, it can be wildly creative, and its answers can change every time you ask. But on the right, we have simulator mode. And in this mode, the AI becomes this machine that follows a set of rules with perfect consistency. It's almost like a piece of software.
The way you get it into that mode is with something called the Natural Language Constraint System, or NLCS. Now, this isn't some clever trick or prompt hack. It's a systematic way of writing rules, in plain English, that the model then adopts as the fundamental, unbreakable laws of its simulated world. It's kind of like handing it a new textbook on physics.
And the effects are just stunning. When you put in AI in this mode, it stops making stuff up. The hallucinations just vanish. It can maintain a consistent train of thought over really long conversations. But here's the most incredible part. You get the exact same results, whether you're using GPT, Claude, or Gemini. This tells us it's not a quirk of one model. It's a fundamental property of how these systems actually work.
Okay, so you're probably asking, how does this actually work under the hood, right? How can a few simple sentences have such a powerful organizing effect on a massive neural network?
Well, the paper proposes this really cool concept it calls vector gravity. So imagine the AI's internal state is like this chaotic cloud of connected ideas or vectors. When you introduce these clear logical rules, they act like a gravitational force, pulling all that chaos into a neat, orderly structure. The model's thinking literally converges around the laws that you've given it.
Let's just walk through the pipeline here to see how it works. First, you just give it the rules in plain language. Then the system organizes those rules by priority. This is the trigger for that vector gravity we just talked about, which reorganizes all the AI's internal concepts. From that new, orderly structure, a coherent world model starts to form. And the final result? The AI pops into that stable, rule-based simulator mode.
The actual implementation of all this is called the S engine. It's basically a set of rules organized into 5 distinct layers, which you can see listed out here. It starts with the absolute basics, the physics engine of the world, like combat, and then it builds up to more complex systems like an economy. Now, the crucial part is that each layer is independent. This is super important because it stops the AI from getting confused by conflicting rules.
All right, this is where it all comes together. Because when you really look at the structure of these rules, you realize you're not just writing prompts anymore. You are, in a very real way, programming.
This slide just illustrates the point perfectly. Look on the left. You've got elements from the NLCS rule set, things like defining distance or an action to decrease a value. Now look on the right. You see their direct equivalents in traditional programming. Their variables, functions, and if-else logic. You are literally using natural language to build the same logical structures that coders build with languages like Python.
So, let's be super clear. This is not just a slightly better way of prompt engineering. It is a completely different paradigm.
With existing prompting, you're basically describing something and hoping for a creative but inconsistent result. With the NLC method, you are inputting a rulebook and telling the AI, simulate a world based on these exact laws. The output isn't creative anymore. It's deductive. It's logical.
This is really the key takeaway. NLCS effectively turns anyone who can write clear, logical sentences into a programmer. A game designer, a novelist, an economist. They aren't just describing a world anymore. They are literally building the engine that makes that world run.
So as you can imagine, the implications of this are absolutely massive, and they stretch way beyond just creating better video games. This could fundamentally change the entire race to build artificial intelligence.
Right now, the AI race is dominated by what the paper calls server capital. Basically, whoever has the most computing power, the biggest servers, wins. But this method, this could shift the competition over to brain capital. Suddenly, it's not just about who can build the biggest model. It's about who can design the most ingenious and effective rule sets to guide that model's thinking. So why does this matter so much? Well, for starters, it could completely democratize AI development. Urban planners could simulate traffic flows. Economists could model policy impacts. Writers could build truly interactive story worlds. And they could do it all without writing a single line of traditional code. It's about creating custom-built intelligence for any task you can dream up.
You know, the white paper was originally written for a Korean audience, and it makes this really powerful geopolitical point with this quote. It's suggesting that a country doesn't have to be the one building these massive foundational AI models to lead the field. Instead, they could become the best in the world at designing the rules that make those models truly intelligent and useful.
So ultimately, this goes so much deeper than just control. NLCS is a tool for designing an AI's internal world model. You're not just telling it what to do. You are shaping its fundamental understanding of cause and effect, of physics, of how an entire world works. You're building its reality from the ground up.
And that leaves us with one final, kind of wild thought. If you could define the laws of a simulated universe, a reality that an AI would live in and reason within, using nothing more than carefully crafted sentences, what kind of world would you build? What rules would you write?